So next up, inverse tangent. So for inverse tangent, we're going to say we're going to start by saying tangent y equals x, and then we're going to do our derivatives. So we're going to have secant squared y dy dx equals 1. So we end up with dy dx equals cosine squared y. So you know the difference on this one is. Sorry, I almost dropped you. Set up here. Okay. The difference on this one is that you have this cosine squared, so we don't have just cosine, we have cosine squared. All right, so then we can put in our y, which is inverse tangent x, so I have cosine squared of inverse tangent of x. So how am I going to handle the squared? Well, I'm not until the end. I'll just drop it till the end, and I'll go ahead and do my triangle for inverse tangent. So let's make a little triangle. I'm going to put theta here, and I know I want theta to be the inverse tangent of x, so that means I want tangent of theta to be x. Tangent is opposite over adjacent, so that's going to be x over 1, so I know I want the opposite to be x and the adjacent to be 1. Of course, by the way, you could have this be 2x and 2 if you want, or 75x and 75. Those are all, right, 2x and 2, or 75x and 75. Those are all similar triangles, so the math is going to work out the same. But of course, why would we do that? We're going to take the simplest possible expression of x as a fraction is x over 1. All right, then do your Pythagoras triangle here. You're going to find that you have square root of 1 plus x squared for your hypotenuse. Alrighty, and then, so we need to know cosine squared. So what we do is we start with what is cosine of theta, right? So our cosine of inverse tangent, since inverse tangent is theta, our cosine of inverse tangent is cosine of theta. All right, so what is the cosine of theta? It is adjacent over hypotenuse. So that is 1 over square root 1 plus x squared. And then, so that's cosine of theta, but we need cosine squared theta. So cosine squared theta, we'll just square that. 1 over square root of 1 plus x squared. The square and square root cancel out, so we just have 1 over 1 plus x squared. Okay, so there you go. That is how you get the derivative of inverse tangent x. So if y is inverse tangent x, then dy dx is equal to cosine squared of inverse tangent, which turns out to be 1 over 1 plus x squared. Now, this particular one for inverse tangent is the most important of the inverse tangent derivatives. So, like, I don't spend a lot of time memorizing inverse sine, inverse cosine. I really have to look those up every time, all right? But inverse tangent, you got to know that one, because inverse tangent is, it shows up in a lot of surprising places. It shows up in integration of rational functions. We're going to see that later this year. It shows up at infinite series. We're going to see that at the end of the year. So this inverse tangent is just going to show up everywhere in very surprising ways. All right, so next, let's see. Next up is going to be inverse cotangent. I'm going to let you do inverse cotangent. So you've got some examples to follow. So we want y equals inverse cotangent of x. So it's going to follow very simply from the same example that we just did. We know the end result because we have it on our chart. It is down here. It's negative 1 over 1 plus x squared. All right. You show that one. You do that one. All right. That one's for you.